All right, this is the first day of product and quotient rule. So we've talked about chain and how chain deals with the powers on exponents when we're doing a derivative. This is product rule. So if we are multiplying two things together, like this would be a product rule situation. Here I've got an x and an e to the x. They're multiplying each other. Here's another product rule. So when I'm multiplying two quantities together, you can do product rule on something simple like a 6x. But since we have power rule, we don't need to do all of the work for a product quotient. We can just kind of skip to the power rule. So when you're doing a product rule, you kind of want to talk about if I had multiple x's, not if I'm just multiplying. Like this would be a power rule. It would just be faster. So you're looking if you have multiple x's, then you kind of want to do a product rule. So this first, quotient rule. So quotient rule is if we're dividing two things. So here I've got a division problem and here I've got another one. We'll talk about how you can solve that. So this is just how these two rules kind of work out. Now they pick usually an F and a G for when they're talking about product rule. And what it says is take the first thing, you might want to write this, times the derivative of the second thing, and then plus the second thing times the derivative of the first. So you kind of do one of each combo. You get one derivative, one plane, and then you flip-flop that, one plane, one derivative. Over here, a little more complicated, it starts with whatever's in the bottom. So the bottom comes first, and then derivative of the top. Remember that little apostrophe or that little tick mark means derivative. Minus, then you flip-flop that, so top times derivative of the bottom, and this is important. The order is important because of the subtraction. You can't turn these two things around. And then all over bottom squared. And we'll do 5 of these, so we'll do lots of practice. What I do kind of have kids do is figure out each of the derivatives so that when we start plugging them in the formula, we're not trying to figure that out in addition to putting it into the formula. So I'm going to write f of x, which is my first function. So 2x cubed. Then I'm going to do the derivative of that first thing. So just in here, so pull the power in front. 3 times 2 is 6, so 6x squared. The g, or the second function, would be x squared minus 3x. And the derivative of that would just be 2x minus 3. So now when we put it together in the product rule, you're not trying to do those power rules while you're also trying to do product. It gets a little overwhelming. So here comes our product rule. So we're going to do f prime of x. And the formula goes the first thing times the derivative of the first. So you're pretty much matching up these two. First thing times derivative of the first. So 2x cubed times 2x minus 3. And then plus, and then you're going to do the other two pairs. So now we're going to do the second thing times the derivative of the first. So x squared minus 3x times 6x squared. We do have a little work here to do. We're going to do some distributing and adding like terms. So this will be 4x to the fourth minus 6x cubed, 6x to the fourth, and negative 18x cubed. So just adding like terms, I'll have 10x to the fourth and negative 24x cubed. Looks good. Another way that you could have solved this, derivatives have lots of ways. I could have just distributed this. So I would have ended up with 2x to the fifth minus 6x to the fourth, and I could have just done power rule. So this would have been 10x4. This would have been 24x cubed. So same thing, either way. Lots of different ways to do all of these types of derivatives. Next up, this is a quotient one. So again, I'm going to figure out our derivatives before we get started. So the u is the bottom thing, so x minus 5. The derivative of this would just be a 1. Then I've got the top thing, and the derivative of that would just be a 3. So as I put this into my formula, it's a little easier when you kind of do the pieces up front. So this formula starts with the thing on the bottom, so x minus 5, excuse me, times the derivative of what's on top. So the derivative up there was just a 3, minus, and then it's the other two matched up. So we did u and v prime, now we'll do u prime and v. So we've got a 3x plus 4 times a 1, all over bottom squared. Doing a little distributing here, so I got 3x minus 15, and then we got minus 3x, and I've got minus 4. One more level of simplify, and I get negative 19 over x minus 5 squared. Couple more to go. This is a product rule. Again, you're looking for how many x's you have, and you have 2 x's. So this x will be our first thing, and this e to the x will be our second thing. So the derivative of an x is 1, and then you might want to look back in your notes, but the derivative of an e to the x is just e to the x. Kind of boring, kind of weird too that it's just itself. And then we're going to put it together in the product rule. So looking up at the top, the product rule says take the first thing, which is x, and we're going to times by the derivative of the second, which is e to the x. And then we're going to flip-flop. So we're going to do second thing, e to the x, and we're going to times by derivative of the first, which is 1. So not really any simplifying to do. We're just going to drop that 1, and then there's my derivative. Excuse me. Next up, number 4, I've got 2 different ways I could solve this one. Kind of like, you have some options here too. We could distribute this, or you could treat it like a product rule because they're being multiplied. 2 different ways got you the same answer. We can treat this as a product rule. They are being multiplied, so we can do that. Another way that I'm going to do this one is I'm going to distribute this to both of these guys. So we're going to end up with 3x squared, and then it's going to have a 2x under it. And we're going to have a 5x, and we're going to have a 2x under it. So we can simplify here by just canceling out one of the x's. So I get 3/2 x, and then canceling out these x's, I have 5/2. And now we're going to do the derivative. We haven't done it yet. All we did was simplify. So the derivative of this is just, oops, sorry, that's a 2. Is just 3/2. Now I'm going to do it as though it was a quotient rule, just so you can see another way. So when two quantities are being multiplied and one's a fraction, they actually share that. So this is my top, this is my bottom. So and I should have used u's and v's here. I'm so sorry about that. Make that be a u, and a u prime, and a v, and a v prime. I was clearly copying and pasting and didn't change it for the quotient rule. So the bottom thing is 2x. The derivative of that would just be 2. The top thing is 3x squared minus 5x. The derivative of that would be 6x minus 5. So if we do the quotient rule, it would be bottom, so 2x, times the derivative of the top, which is going to be the 6x minus 5, minus, then you've got the top, which is 3x squared minus 5x, times the derivative of the bottom, which is just a 2, all over bottom squared. Make sure you get that in parentheses. Distribute, I get 12x squared minus 10x. Minus, I'm going to do 2 distributes at once. I'm going to distribute the minus and the 2, so that'll make 6x squared. I'm going to distribute the minus and the 2, so that'll be 10x. Oops, just 10x. And then on the bottom, we got 4x squared. So on top, I have 10x and 10x. These guys make 6x squared over 4x. Cancel out one of those. And then I'm going to, oops, where did I miss a squared? Oh, down here. My bad. That's a squared. They both go. I missed that. Then I have 6 over 4, which is just 3/2. So same derivative either way. One more to go. I've got multiple x's, and we are multiplying, so I'm going to do the product rule. So the first thing is just my ln of x. The derivative of that is 1 over x. My second thing is 6x squared. My derivative of that is 12x. So first thing is ln x. Derivative of the second thing is 12x. And then second thing is 6x squared. And derivative of the first is 1 over x. There's not much you can simplify here. We do like the ln x to kind of be the last thing you write, so there's nothing really tacked on there. And then one of those x's can cancel with one of those, so then I get a 6x. There you go. So just some different ways to do both the product and the quotient rule. And again, there's often more than one way to do a derivative. So don't think if you're doing it different than somebody else, that means it's wrong.